several familiar faces here. I'm Scott Buek. I've been the regional manager for Trerice now, going into my 14th year. I've got 30 years in the business, so I hope I've learned a little bit about gauges, thermometers, diaphragm seals, and I do say one of the nice things I like, or one of the things I like about my job that's kept me in the business is no 2 days are basically the same anymore. Everything's different. Different applications, different things, and that's where I learn, and hopefully I can share some of that information this morning. There's some information on your desk. I have some flyers. The first flyer is just a kind of a general product flyer. Jim has brought up some of what we did for you with the IPS logo on it, which is for everyone. Either you can mail them out or the guys to hand them out rather than the full product line catalog. So that's just kind of, this just kind of gives an overview of some thermometers, some gauges, the temperature regulators, which we're not going to get into today. That's almost another whole session by itself. Not too many calls for them because that's kind of a science that's kind of going away because you don't have the manufacturing that you used to, but you still have a lot of the old boilers in hospitals and some schools, but they're slowly being replaced. Our business stays pretty steady because a lot of other companies are getting out of them, and the guy that bought Trerice about 18 years ago, to his credit, he has not designed down our control valves. They pretty much have stayed the same. They tend to be now a little pricey compared to some of the foreign stuff that's coming in. All ours are domestic, but you know, once you put them in, they basically work forever. As many as those that are even being replaced, some of them can be 20, 30 years old, so they last a very long time. So that's that. Then I have, and if you've been in my session before, I just put this kind of sheet out. Ask a question anytime you want. Interrupt me, please, so I can catch your, give me an answer. The first thing is how to choose a pressure gauge, and this is really, it just takes time to come together with that. There are 7 points, and they don't necessarily go in that order. What is the process media? What are they putting it on? Is it just water? Is it something caustic? Is it oil? Is it gas? You obviously need to know the pressure range, the environment being outside, whether you want a steel case or a stainless steel case, your accuracy, and I'll get into this in a second with the gauges. Your accuracy, 0.5%, 1%, 1.6, 3.2, 3.23, I'll explain that. Your dial size, 1.5 inches up to 12 inches. Your connection, 1/8, 1/4, 1/2, lower or back connect. Mounting requirements, lower back or U-clamp. I think most of your calls fall into 2 areas. One is the kind of industrial, and the other is the commercial. And there's kind of 2 sets of gauges, and I have the gauges here, and it's kind of a good, better, best. I've been to a lot of engineering firms lately that are trying to clean up their specifications. A lot of them got involved in what is known as the master spec, and it got to be very generic. They listed the steel case gauge for liquid filled. Steel case gauge and liquid filled is going to rust and not hold up. Master spec wants to fix it, and they say, well, if you want to get involved and send a check in, a sizable check in, we'll sit down with you and go over the specifications. That just makes it easier for everybody else. So we've decided not to do that, but we do go in, and I will go in with anybody here in the area. Actually, I've been to a few in the area, where I will go in with your sales guys and work with people on their specifications. So one gauge that I'm not carrying with me at the good end of it is just the steel case gauge. It's exactly that, steel case, steel ring with a lens. This happens to be the gas test gauge. This is a 2-inch. Most of what you see is going to be a 2.5 inch, that size, steel case. And I think that's the 800B, which you are probably familiar with. That is a 1.6%. I'm going to wait till I get to a larger gauge to go into the accuracy. Then the next step up is the D80 series, and you have a D82, which is your brass socket, and you have a D83, which is your stainless steel socket. So these are both 1.6. One happens to be liquid filled, one is dry. Liquid filled gauges are used when there's vibration or pulsation. Those have a crimped ring on it, so they cannot be recalibrated. Extremely price competitive. We do source them in from a supplier offshore that we've had, well, as long as I've been with Trerice, and even longer, a pretty consistent supplier. The D80 series are pretty good gauges, both of them, and they're both very price competitive. Yeah, different plugs, I'm not sure why, other than maybe different times when I got it. I think we've pretty much standardized on the little clip the nipple on the top. Yeah, that one. Some people will cut it. There is a way that you can burp it, what we refer to as burping. If you hear that somebody gets a gauge and it's a pound or two up, you take your fingernail or a little screwdriver, and all you have to do is just, you relieve the plastic nub on the top, and you'll see it, many times it'll move. We had somebody in South Jersey got a bunch of them, and they got like 25, and like 6 of them were off zero. And they said, oh, these gauges aren't calibrated. They tried to calibrate them, couldn't get them calibrated, sent back to the plant. One was not where it should have been. The other 4 or 5 just needed to be burped, and they came down. That's just been around forever. What happens is you've got a liquid in there that can build up pressure, and if it warms up, it can expand, and it can actually affect the tube. Once you get it, from offshore to Detroit to South Jersey, it may be up in a plane, it may be in a truck, it's going to see heat, it's going to see cold, so it's going to change. And that can have an effect. And that doesn't matter whether it's a 1.5 or I think we go up to 6-inch liquid filled. It can affect all of them the same way. The next step up on the kind of the more higher end on the industrial side is the 700 series. Now these are a 1%. These have a ring that will come off. This is the 2.5, this is the 4-inch, available in brass or stainless steel wetted parts, and I'll get into that in a second. That is a more expensive gauge. As you start to work your way up into being more stainless and at better accuracy, you also get into a higher price. Okay, let's talk accuracy. Let's just take a 0 to 100 psi, and if it's a 1%, like those gauges are, you can be plus or minus 1 psi, 1% on a 0 to 100. So it's actually a variance of 2 psi, plus or minus 1 pound, 1% on this gauge. On a 1.6, it's plus or minus 1.6 either side. When you go to a 0.5%, it's half a pound. On 0 to 100, it's a half a pound, plus or minus a 0.5%, or a half a pound on a 0 to 100 psi. Everybody manufactures to the same standard. Wyka, Ashcroft, Winters, that is one thing that is consistent when it comes to gauges. There's the boiler specs that go back 150 years that everybody has to calibrate, and everybody manufactures to the same calibration standards. That's pretty consistent throughout. Now I have going to kind of move into the commercial side of things now. This is the 620B. This is the low end, kind of entry level import gauge that we get. It meets the spec. It has a stainless steel external case. It is a brass socket. It is a 1%. It's a 4.5-inch dial. This is for HVAC going into institutions, colleges, hospitals, commercial buildings of any size. This is the good of the good, better, best gauge. There's a lot of these around. Then we go into the 600 CV, which we bring some component parts into Detroit, but we manufacture, calibrate, assemble, package, and this is now considered it's enough of a percentage to make it a ARRA or Made in USA gauge. Has the aluminum case, has a chrome ring, has an adjustable pointer. It too is a 1%. You'll see that it's a heavier gauge. I'm going to pass this one around though, because you're going to see. Here's what the gauge looks like. The 2-inch gauge looks like this inside. The 4.5-inch gauge looks like that inside. The 2.5, this 4.5. If I had a 6, this is a board-on tube. And the board-on tube starts out as a long ribbon. Depending on the range, then the thickness and the size, it will be rolled, welded, flattened, and curved. And then it will be attached onto the socket. And then there's a little gearing in there, and it's all the science of, I mean, you open up a locomotive steam gauge going back 140 years ago, the tube may be different because they had to make them differently because of technology at that point. But basically it's going to be a board-on tube, which came from Bourdon, France. And what happened when you put the pressure, when the pressure goes into it, the tube is going to try to straighten out to its original back to the old tube. It's going to try to straighten out. I wanted to get some party favors. You have kids, you have the party favors, you blow out, blow into it, it rolls out. You let the pressure out, it comes back. If you pull a vacuum, if you suck on it and pull a vacuum, it actually gets tighter. That's a board-on tube. It's basically what a board-on tube is doing. So as the pressure goes up into it, it's going to try to expand and straighten out. And if it actually pulls a vacuum on it, it's going to pull down. I'm going to pass this around with it at the same time. This is a snubber. This is key to making the gauges last much longer. You'll see that it has a centered center to it. So if there's a lot of pressure that goes through it, rather than go through and just go through the hole and stress out the tube, this is going to slow it down. You or I won't be able to tell the difference, but it's enough to slow the pressure down. And if there's any kind of a spike when a pump comes on or anything like that, or a valve is turned, it will dampen it down. And you can play with that. You can push it up, push it down, and see what happens with that. Whether it's a brass tube, whether it's a stainless steel tube, it will do the same thing. Back to that on the wetted parts on one of the 7 points. Most of what goes into the commercial HVAC is brass. You get more into anywhere around food, anywhere around heavier processes, then they will go to stainless steel. In the bad chemicals around the oil field, you get into a Monel. I don't know that I've ever had the requirement of Monel in this area. Then you can go to a diaphragm seal and completely cut it off from the gauge. But and that takes into point 2 on the brass. Back in January of 2012, we had changed our inventory over from the standard leaded socket to the lead-free socket. And it's not 100% lead-free, but it is down to a very minor amount, which is allowable by California law, which is this is all being pushed from. And a lot of our gauges now, what you'll see on the gauge front, we started with a stamp to socket, with a circle with a line through it with PB. PB is on the material metal chart or whatever, and so it's no lead, no PB. We also, this past year, moved all our inventory over. We now have ANSI and NF 61 and 372, that is on the dial, and we have the UL approval for water quality, not fire protection, only water quality. We have a third party comes in, picks stock off our shelves, takes it out, checks it, gives it back to us, tells us when we're good, tells us when we're not so good. And then we keep that up to date. That happens all the time. So there are some others out there that may have lead-free. They may have NSF. I don't know of another one that has, which is good, but we do them both. We have two different certifications on here. I don't know of anybody else that has the NSF and the UL. So we're covered by both agencies that this is no lead. And when I say no lead, and you get down into when product goes into California, if you don't have it properly marked, there are people out there looking to sue the distributor or whoever sends it out. That other company called Ferguson down in North Carolina sent some product to California about a year ago, and it was a thermal well, and it wasn't ours, fortunately. And they're kind of in court right now. There's people out there waiting for people to send product out there that's not marked. We have warnings, we're putting warnings, this product contains the chemicals known to the state of California to cause cancer and birth defects or other reproductive harm. And that actually is this was the 2.5 inch liquid filled with everything on the dial, and we're still putting the warning on there because there's always somebody out there looking to sue. So we're seeing more and more of that. We're seeing more requirements of the lead-free. All your bathroom fixtures, anything with water. I did a presentation up with the New York Housing Authority several years ago, and they said, well, we really appreciate what you're doing for going towards lead-free, but we have more lead out in the pipes on the street than we're ever going to have to be concerned of here. However, everything that goes through for the Housing Authority in New York City and the 5 boroughs all now states lead-free, not just on any component. You know, any valves, any shut-off valves, any regulators, any gauges, anything that touches drinking water has to be lead-free. And when you go to lead-free, the cost is about 25% higher when you go to the accessories. We incorporated it, when it comes to the gauge, it's basically the socket of the gauge. It's not the board on tube, it's the socket that matters. So the cost was a very minor increase. Other manufacturers, actually, Ashcroft just dropped their lead-free through Wexler, so I don't even know that they're going to have anything available. Winters has Wyca has a couple gauges. I think they have some 2.5 and 3.5 inch on almost like a metal case. I don't think it's in a stainless steel. Winters has leaded and non-leaded, and then they have different part numbers and they have a different price. Nice thing about Trerice and the distributor, we have one. We never changed we didn't change the part number. We kept the part number the same. It was incorporated into a pricing in 2012 when we started this. By the way, current 2016 pricing is still good, although we probably will have an increase come January 1st. 3 years. Of course, now with the trade wars going on, who knows? So we do make it simple because we have the one, except when it comes to accessories. Okay, we still have the leaded accessories and we have the non-leaded accessories, and it's about a 20 to 25% difference. And we have the same part number, but at the end we have PBF, lead-free. And that's the difference on that. It's in the price sheet. We have them for the ball valves, for the PT plugs, for the snubbers, for the instrument valves. I don't know whether you stock any of the lead-free here.
We have some wells.
Do you have some wells? Mm-hmm. Okay. It's kind of one of those things that we're just still waiting to see how it's going to go. We have the full inventory out in Detroit, so to have a few here is fine. If they're not moving because it's going to be selective who wants it, we get people who are going to do a commercial system and it's a closed system, not drinking water, but they want lead-free. Hospitals maybe, hospitals, some universities with new facilities may be saying, we absolutely want everything has to be lead-free. I've been going through a nightmare lately. There's a project going on at Harvard, and what they want us to provide for information to say how friendly these things are, it's like it's a task within itself. It's probably beyond what was done for the California law, but they want to be greener than green. And it kind of gets down to the point, it's like, look, if you don't like the brass, go with stainless steel. But stainless steel is going to cost 2 to 3 times
Right.
what the brass is going to be. And years ago, when somebody was looking for, and I was involved with my previous employee with fire, UL fire gauges, that the customer had requested lead-free brass, and we had to order in some sockets, some sockets in from Germany, and it was phenomenally expensive. But that's going back probably 20, 25 years ago now. Now it's every day. I mean, the whole science has come together, and the volume drives the price down and makes it more reasonable. But with when people wanted lead-free for some reason or another, or were aware of it, your only option, actually going back before 2012, was really go to stainless steel. So
Now, are the snubbers lead-free?
lead or lead-free,
You get both
you can
ways,
get
okay.
them either
They
way.
have them either way.
All the accessories are the same, and the snubber is again, it's a very
What do we stock?
Just the regular one.
We don't stock lead-free
No.
snubber.
The only thing I think we stock lead-free is the wells.
Okay.
yeah, you might think about some snubbers, only because if somebody's putting something with this on water and they want it that way, you've got it. They'll never go bad. But the snubber is almost and actually, really, if you send anything into the factory and ask us to quote back on it, or you send a specification, there are always snubbers in there. Snubbers are an insurance policy to the gauge lasting longer, especially with the lower cost gauges with the brass.
We have a lot of people that don't use them.
Now, a lot of people don't. Now, there's a good side and a bad side to a snubber. They can clog. If there's junk in the line, they can clog. But in time, that gauge will clog too.
Yeah.
It's just gonna be inaccurate
And
gauges.
so many times you turn the valve off, you take the gauge off, and you take the snubber off, and if the gauge goes down, then you know you're only replacing a $4 item instead of maybe a $50 or $60
Right.
item. There's also the Ashcroft has the XLL, or the flutter guard, or acting a gauge that acts like a dry gauge. And basically what they've done is it's not a snubber, it's a throttle plug, which is like a little top hat that they push inside and has a pinhole in it. Then they do lubricate the gearing, which we can do on the 600s, we can do it on the 500s. Put a throttle plug, we can do the same thing. There was kind of more smoke and mirrors with that. I was still with them when that was all going through, and they sell that a lot into the refiners in the process. Refineries anymore, they don't pay to have the gauges. Gauges cost less now than they've probably ever cost, and they just throw them out, and they clog. I mean, it happens. It's a one-way street. If something gets up into that board-on tube, there's no way for it to flush back out again. So if something hot gets up in there and it cools down, it can basically freeze up the gauge, or eventually, if there is a lot of material in there, it can get up there and eventually the gauge has to be replaced. It's the same way with a liquid fill gauge. I like to say our liquid fill gauges never leak, but once you put a liquid in there and you have temperature changes, there are a few that do. The crimped ring is probably the best way to go, because it's a solid way of doing it. It's a mechanical way that we shut it down. Whereas the turned ring, if that doesn't get back on just right, it can possibly leak. Nice thing about the glycerin, if the glycerin leaks, it's not a problem to clean up, but if you put silicone in there because you have the temperature extremes, it can be a mess to clean up. Okay, we're about halfway through. So
What is the proper procedure on a liquid filled gauge after the customer installs? It's always been you cut that rubber nipple off, you don't
Right.
cut it off, you just, you know what I mean? There's always back and forth.
Well, I just personally, with my long-term, once it's in place, it's generally gonna be okay.
Mhm.
So if you do the little burp on the top of it, it's probably gonna be okay.
Okay.
I think it said right on it to cut it off.
Well, it does say to cut it off, but if you then lay it down, for some reason, it's gonna leak.
Mm.
And then that makes it messy. On the upper, on the 1%ers, even the little flip top, I don't know whether you noticed it or not, but there's a little groove in there, so if you turn it one way, it's supposed to be able to, it breathes. If you turn it the other way, it turns it off. These can leak too.
Mhm.
There's no, once you lay it down, if you know, or even put it this way, they can leak. I mean, Ashcroft even went to this type. There's a couple now, they have a little pull piston. I don't know, everybody's trying everything, but the bottom line is, once it's like that or like that, they can leak, they can weep.
Before you go into the thermometers, which I
Yep.
think is what you're gonna do, when somebody tells you they want a gauge to be calibrated, what
Okay.
exactly is that, and why does it take so long to have
Okay,
it done?
well, all right, when we assemble the gauges and we calibrate them, we take them up to different points on the dial to make sure that it is in a 1%. Okay, if it's a 0 to 300 or 0 to 160 or 60 or 100, we do that. But we do it. We have multiple ones on there. We're running them all up. We're tweaking them. We're doing whatever we have to do. We get them into the 1%. When somebody wants a calibration certificate, that means we have to run it up individually. That means we have to have a sheet. We have to put it on there. We have to calibrate it. Some want 3 points. Some want 5 points. It's just a labor intensive, and no, it should not take as long as it does. Even liquid filling a gauge out there should not take as long as it does, which we're gonna have another conversation on that this week on a case of mine. And if you need it through faster, give me a call, or you tell your customer service person, by the way, and I have to get that out to you. You did get notice, Christy is taking over for Brian. Brian Trakoff has moved up into an accounting position. He's still afternoons for a while, still working the desk and helping out. We finally, after 3 months, had some people come in that we were interested in interviewing. We were having a very difficult time hiring people for inside. We're looking for 2 with some kind of background or interest in it anyhow. Detroit's very different today than it was back in 2008 or prior to that. They either moved out or the job market has gotten better out there.
So you're just basically checking the,
You're reconfirming it,
okay,
but the downside of it is when they take that gauge off and actually put it in the box, it could change.
oh yeah,
Or UPS delivers it to you or the customer and it gets thrown, it could change. It's good at the point that it's there on the calibration stand, and it's what, $30 or $40 net each. Actually, the bimetals, which I've struggled with lately, it's like $30 a point. So it's like $90 for 3, $150 for 5.
yeah.
That shuts that down right away. I mean, there's no guarantee. It doesn't matter whose gauge it is, that from the point that it gets off that calibration stand to the customer, that it's going to do that. But it would take a pretty good hit for it to knock off of it, or at least it's going to be darn close to where it's
Okay.
supposed to be. Okay. But it's a matter of getting somebody over to do that. They probably don't like to do it for just 1 or 2. They probably, it's like, if we can wait a week, then we'll have a couple, then we set it up, get it going, because I think they do, I think it's a computerized printed sheet now. Used to be all manual, everything had to be manual, but now there are computer programs that do that. Which, yes, makes it easier, it makes it nicer to look at, but it still takes the time to do it.
Right.
And that's why. It's separate, set aside time just to do that function. So that's why it's expensive, that's why it's probably just not done every day. Because even when the gauges are, even in the normal production, just because it's on the manifold being assembled and being checked for calibration that it's in 1%, that's not where the cal sheets are done. That's a whole nother separate operation. That's why I'm doing it.
Thank you.
Yep. Again, you know, I mean, it's, when the call comes in, somebody's looking for a gauge, the first thing I would ask for is, well, what size are you looking for? 2.5, 4, 4.5? No, yeah, 2.5 will be good. Okay, what's it going on? Yeah, water or just watching a pump? Okay, so what range do you want? And generally, you want where he's operating to be in the upper part of the range. Actually, they say even the top 50%. So on a 0 to 100, it would be from 25 to 75. Right? I think my math's right there. You don't want it in the bottom quarter. You don't want it in the top quarter. You want it in the mid. But the closer you can get it to between 11 and 1 o'clock, that's where it will work the best for the longest period of time. And if it's at the point to say, well, it's going to be a little higher, then go to a 160 and have it a little bit on the lower side rather than the higher side. Because if it's getting close up to the 1 or the 2 o'clock range on the range, then it may go beyond that. Then you're going to stress the tube. So, you know, you can always be on the safe side of lower, but generally you want it in the mid part of the range. And then I'll move on in a second. I had said the 1% is full scale. The 1.6% is full scale. Not our gauges, but there are others out there, because you may see it in a specification or you may see it on paper, is a 323. And they're talking about it's 3% in the first quarter, it's 3% in the last quarter, and it's 2% in the mid-range. Not real accurate when you're looking at when we say a 1.6, and there are others that do the 1.6, but generally even our little 800Bs are 1.6. I know there are others out there that are 323s, so they're a whole lot less accurate. You know, we're ready. You know, we put our name on those, and that's the other thing. There's some manufacturers import from offshore. We do too. You have to in order to be price competitive, but you'll always. Of course, the one I'm holding up doesn't have Trerice on there because this goes into the plumbing market. But for the 800Bs, everything that you will find in this catalog has our name on it, and we back it up with it. So if there's a problem with it, they know where to come back to. Okay.
The accuracy, is that just lower quality products inside? The board on dues not as good, or is it just?
Well, let's say if you can't, if your system can't meet a 1% test,
Right.
can it meet a 1.6 test? Probably can. Okay, so they start out. Let's do what we can for the 1%ers, because they'll hold to the 1%. They don't make the 1%, as long as they're good at the 1.6, we can use them in the 1.6. And it doesn't make them any less accurate, it's just that they can't tune them as tight as they need to be to keep that accuracy statement. So, but you know, it's a brass internal versus a stainless steel internal. The 450s and the 500Xs have the stainless steel, which I'm sorry that I don't have to show you, but instead of the brass gearing, it's stainless steel gearing. Well, the stainless steel gearing will last longer. It will see more cycles than the brass. The brass is softer, the stainless steel is harder. So that's where you get your good, better, best, and that's where you get your lower price, mid price, higher price.
So when that needle's laying up there, like, at say 90 on a 160-pound gauge, what actually happened to make that needle up there? Is that tube
Probably
that's...
solid overpressure.
Okay.
I've seen once in my life at the old mobile refinery. It's now multiple names down in Philadelphia, and it was a process gauge which had a bigger tube than this. And when it sees a gauge can stay calibrated if it sees 125%, 25% over its range, as long as it comes down. And you don't want it to keep doing that because then it won't keep it. But it was supposed to have been a 0 to 300, and I think it was 100. And it saw an overpressure, so that tube actually stretched out to the inside of the case. Now, years ago, it would have blown because the tubes were actually drawn. They were stretched. being now the way they make them, they're more consistent in the thickness of the tube. When you drew them out, where they said drawn tube, the thickness varies. It would be like pulling taffy or whatever. You can get thick parts and thin parts. You couldn't stay consistent. So I've seen pictures of blown tubes, and I mean literally, they just blew apart. That's 2, and I don't have the 450. On the 450, the process gauge, it's a solid front, blowout back, and that's why they came out with that. Basically, they took a gauge, they put the dial on the back at the face of the gauge, and that's the 450, which I think we show it on page 4. It basically shows they put the face on the back of the gauge. Yeah, they elongated it. They put a window, but the system, which was the old front, is now the back. So if it did blow, it didn't blow into the face of the operator. It blew out the back of the gauge. So that's a solid front, blowout back. It was a safety factor years ago, because that's in all your refineries, chemical plants. That was a gauge that was used. Today, it's still a factor. It's still a safety. It's still in there, but again, I've only seen one severely overpressured, and I'm sure there's more, and I'm sure there's been some blowouts or whatever. But I mean, boy, and when that happened down at Mobile, they called, and it wasn't, fortunately, it wasn't the gauge I was representing at the time, but it was somebody else's. But it was operator error. They put the wrong gauge in, wrong range in. So when they realized that, they realized there wasn't anybody that they could point at, because there are limits to what these gauges can do. They're very thin walled. You're not going to go throwing your watch down on a concrete floor. It's not going to last. These are the same thing. It doesn't take a lot to knock these out. I can throw it across and it'll calibrate, or I can go like this and I can knock it out 3%. They're sensitive instruments. They're very sensitive instruments. Just to run onto thermometers.
One of the best things is if the gauge isn't working, you see somebody go up and smack the
Smack
side
it.
of it.
Yeah, well,
That's the worst.
Yeah, you can
Then
do
your
that.
needle's like this.
Many
I'm like, I
times-
don't know what I'm doing.
Well, what they do is they will tap it, because the friction can build up in there, and many times you'll see them tap, and that's okay. That's okay. When it's in place, that's okay. But to take a wrench to it or something, no, that's not. And actually, when they calibrate them, they're tapping them all the time. I mean, they're just down the line. They tap them just to take the friction out of it. So.
Most of the time, you see pressure gauges fail is an overpressure condition. They get spikes in the system or something like that. That's what we're going to see most of the time. That's why people call us for gauges. They get water hammers. They get steam. It's just shock. That's what we're seeing all the time.
Well, and that's key too with when you have anybody with steam. They've got to have a pigtail siphon on it. Okay, so you're going to have your valve, you have your pigtail. They need to know, and they should know that when they install them, there has to be water in here, because it's the water that compresses that doesn't allow it to shoot up. Steam is fast, it's hard, and it'll blow anybody's tube. Doesn't matter who the manufacturer is. If there's no water in here, or they don't have a siphon, it'll blow anybody's tube. So there's water in here, and what it does is it stops it from spiking up. You've got the ball valve, which yes, you can turn off or turn down, or even use the instrument. You've got the snubber, and basically what you're doing is protecting the tube. So, that's, and then this goes into the pipe. So many times that's what you're gonna see, right there. And to have the ball valve on there, that way you can take this off if you need to, and not stop the pressure. I've seen it, I've got pictures on my phone where people just literally, this is inches off of the pipe housing into a pump. And the guy called me, and this is the Constitution Center down in Philadelphia. Well, your gauges don't last. I said, well, do you have any of the old ones? No, the outside mechanical contractor came in and took them all out. He says, your gauges and they were the 600 CBs, which I pretty well, these are what are in the New World Trade building up in New York. There's probably 800 or 900 of these in that building. I stand very well behind these. And I said, well, they're really good gauges, but you're on a pump housing. Every time that pump goes on, it's just shooting into it. So, being our Constitution Center in Philadelphia, I gave him some 4-inch D82s, liquid filled, with the snubbers, with the shut-off valves. And I said, and let me know how it works. Well, that's been like 8 months, and I haven't heard back from them. So I don't know whether they got them on it or not. But and of course, they bought it through a catalog house that doesn't buy many, but they can buy from us out in the Midwest, and he didn't call them to come in and help him. But I'm Mr. Trerice, so I'm there. I'll do it for anybody, if there's a problem. Okay, the most sold thermometer is going to be the BX9 1403, which is from 30 to 240. It is the 9-inch aluminum case. Oh, geez, I printed all these. Here's your catalog page. Yes, I have color, you have black and white. This is the D80. Okay, so on the how to order, we're gonna go back on gauges for a second here. How to order, you have the D82 LFB or D83 LF being liquid filled brass or liquid filled stainless steel, or in the dry. You pick your dial size, you pick your connection, lower, PSI or dual scale, or there are others. And then on the second page, there are your ranges. Now that is the one funky thing about Trerice. If you want a 0 to 100 PSI, the code is 110. I don't know where it came from. They came up with it 85 years ago, and that's the way it is, and they won't change it. And I don't, it's. I guess if you've worked with it long enough, you know it. I know it. I still have to look, but I can't remember them all. So it really walks you across. So you want a D82 LFB like this one. D82 LFB 2502 LA and 110 is the code. So that's, and then you have the specifications. Now, what an engineer may want you to do is you might circle those. You can print these off the internet. This is what's in the catalog. Easy to print it off. You circle it, and you can check off up here because it's the DD2 LFB, liquid filled. You circle your 2.5 inch. It's glycerin, the movement, the brass, the connection, the case, the ring, the windows acrylic, your accuracy 1.6, your temperature, and it's all there. And you can use that as a submittal. On the 600 CB, I think I only gave you the front page because the second page is very much the same. Now on the 600 CB, it's available in a 3.5 and a 4.5 inch. The 3.5 inch, for some reason, is about 25% more than the 4.5 inch because the 4.5 inch is the standard size. So it's the 600 CB 4502LA, your range. Again, you can check off your specifications. And on this second page, which I did not include, is very similar to the other, you pick your range. And each one, when you're in the catalog or on the internet, they're face to face that way. So you're either looking at one page, you scroll down to the second page, it's right there. Same thing with the 600 CB is the same way. Very easy, very user friendly. Pretty well get that in front of a customer and they'll be pretty good. Okay, now let's get on to the thermometers. Where's the rest of my paperwork here. The BX9 1403 is kind of the standard in the industry. It's an aluminum case. It's the only way we do it. There are plastic cases out there. They may be a couple dollars less, but generally pretty much when you're talking to institutions or anybody that uses a lot of these, they like the aluminum case because they don't break that easily. The plastic case will break easier, because many times these can get hit. People will climb on them, or if they're putting a ladder up, or, you know, they have an extension cord. It doesn't take a lot to break a plastic case. Yes, sometimes you hit it hard enough, the aluminum case will break. It's got the joint down there, so it can happen. We also have a 7-inch case, and we have a 12-inch case. This is pretty much the one that's used everywhere. The 7-inch is used in tight spaces. It's the same price as the 9-inch case. We have them. We have most of the ranges in stock. We have all the ranges in stock on the 9-inch, and we have these by the thousands in Detroit, made ahead of time. This is we have sold consistently every year more of these gauges every single year. We keep being reminded, what are you going to do for me this year? You've got to sell more than last year, and we have. We've been very successful with these gauges.
Thermometer.
The thermometer, thank you. 3.5-inch aluminum stem. You can also get them in the 6, the 8, and the 12, although the 3.5 and the 6. 3.5 is by far the most used one, and then second would be some 6-inch, and that's where it gets a little bit more confusing. And you'll see the order across the bottom: EX9, 9-inch adjustable, 1, 403 for 3.5-inch, and then pick your range. We still do a brass stem. Now, years ago, these had brass stems. It's a matter of cost, and everybody's pretty well standard on the aluminum stem now. Brass is optional. 304 stainless steel is optional. Brass, if somebody really wants it, I can understand it. I don't know why you would do a 304 stainless steel, because all of your thermometers, wherever there's pressure or temperature, need to have a shut-off valve or a thermal well. And having a thermal well allows them to pull the thermometer out and not have the process come out. So actually they have the fitting goes into the pipe, which is really what my high temp board is. Okay, goes. No, it goes in that way. I know it goes in that way. There you go. Okay, this is welded to the pipe, which is basically what I'm showing here. All right, screws in. The thermometer just goes in, and then they screw it in, and they can adjust it. You loosen the screw on the side, and you can tilt it. Okay, now this is where it gets confusing. And if you look at that sheet for the thermal well, okay, 3.5-inch stem. You'll see it over on the left-hand side, lengths. 3.5-inch stem, standard U dimension, and the U dimension is the dimension that is inside the pipe, is 2.5 inches. If they have insulation, and like 1-inch insulation, then you go over, just move over to with lagging extension. This is the 1-inch. Now, you still use the 3.5-inch stem, but what it does is it has to take it somewhere. It takes it out of the process. Okay, these aren't in all the way, so it looks a little deceiving. Get that all the way in. So now this backs off. It takes 1 inch from here, and it basically puts it up here to allow for 1 inch of insulation. If they want more than 1 inch of insulation, and they still only want the small amount into the pipe, then they've got to go with a 6-inch stem that gives you, and you'll see 6-inch stem, the standard would give you 5 inches insertion, but if you want it lagging for insulation to give you 3 inches up here, then your U length, or what goes into the pipe, is only 2.5 inches. But you need the 6-inch stem to go in here. Okay. I remember 30 years ago, working on wells was kind of confusing. And then all of a sudden the light does go on. It's not that bad and that's why I kind of put this together, because it really, the term lagging just threw me off. I wasn't familiar with it at all. But lagging obviously is like backing it off. And maybe if it's a smaller pipe, it doesn't necessarily have to be 1 inch insulation. Generally speaking, you want the stem length to be about 1/3 to no more than 1/2 of the diameter of the pipe. So if they're using a smaller pipe and they still want to use this thermometer, then they can get away with the 1.1 3/4 inch insertion. Now, they may have to put it into a T in order to get it in there. I've seen a lot of different ways to do it. They can do a T, they can insert it into an elbow. There's a lot of different ways that they can get around by not inserting it as much. But this is basically one way to do it versus the standard insertion to back it out 1 inch. But again, if they want a lot of insulation, which a lot of these piping do require, then they have to use a 6-inch thermometer. Now, up goes the price of the thermometer, up goes the price of the stem. Because what happens if you want to add an inch of insulation or a couple inches of insulation, it's fine for when the thermometer will go in before the insulation, and then they do this nice job of just bringing that insulation right up to here. And then the thermometer gets hit. Then they got to dig this all out, all around the insulation in order to get the thermometer out. And then it's a mess. Okay? And the mechanicals many times will do that because obviously this is going to be less expensive than going this route. But this route gives you the extension and allows you to do the insulation. If it has to pull out, then it's easy to just take it out from there. Okay? This is 3.5 inch stem, but it gives you the same idea. Okay? Then you can have the insulation. Then you can take it out easily. On the bottom, 3 inches the industrial. Industrial generally is pretty much the 3/4 inch NPT. For the F, the 3.5 inch stem. Now this would be this one here with the 1 inch lag is the A. But if you go with the 6-inch stem, then you go to the D, and then brass. So basically the one you would have in stock is the 3-4 F2, the standard one. And if anybody wants, I don't know whether you have any of the 1 inch lag or not.
We have it listed as a extra, but we don't stock them.
Yeah.
And then we also have the lead-free ones
Yeah,
listed.
and we've got them in stock in Detroit. So, and we are pretty good. If you tell whomever, Christy now, or it was Brian or whoever, you get the order in by 2 o'clock on 1 or 2 items, and it's like, can you really please try to get this out for me today? There's a pretty good chance they can, as long as it's something easy and it's not something they have to put together. And if not today, can you get it out tomorrow? Now, from Detroit to New Jersey, they get it out Monday afternoon, I get it Wednesday afternoon. I would think you're probably the same here, so that's pretty good. Why pay second day? Of course, the time you don't do it, and don't pay the second day UPS is the day that it doesn't get delivered. At least it's not coming through the mail. You may never get it. Now, the other way to tell temperature is the bimetal thermometer. This is for my former employee, a 5-inch dial. It is a rear connect. The factory is making me some 3-inch with a 1/2-inch connection with the tube. This is what the bimetal is all about down here. It's 2 different metals, and as it heats or cools, it coils or uncoils. It's welded inside here. The pinion comes up. This is a little thing so it doesn't bind, so it stays in the center. And as it coils or uncoils, it turns the pinion, and it then turns the pointer. Okay? And this is the external adjust for calibration. This is a one of. I was able to get that from the factory, oh, good 20, well, Tyler is 23 years old, so that's 23 years old. But I will have a smaller sample to hang around. I'm surprised it's survived. But that basically is what a bimetal thermometer is. Now, when you get into the wells for a bimetal, this is a true bimetal stem. That's bigger because of how they had to show it. This is the half-inch connection, which is on there. This is the quarter-inch stem. So you obviously have to have a different well for it. This is, by the way, the solar thermometer. And then it goes in. This happens to have the 1-inch lag to it. You can get it pretty much the same way, but they are different. Bimetal stems are 2.5, 4, 6, 9, same price, any one you do. And then 12, 18, and we've done 24 and 36 on stems. I'm seeing the universities, depending if it's a private where they have more money, are going more to the bimetals away from these. Your net on these is around $22. Your net for a 5-inch bimetal is, I'm going to say, about $45, so it's about twice as much, which is why these are so much in the basement, because they've always been less money. But they're like a gauge. They're more visible. You hold when they're behind you and you're looking and you're walking by. If that pointer's up in the mid-range, you keep on walking. With these, you have to go and you have to angle yourself. You have to look to see where the fill is. Speaking of the fill, we're standardized on the blue fill. I was at an engineering company 2 weeks ago in Connecticut, and they said, well, do you do the red? I said, yes, we will do the new red, but I said that's the difference with the blue, because the old mercury many times would show up as red. That's why we're blue. And I would recommend you stay with the blue, because anybody walking through and seeing red generally should know it's time to get rid of it, get rid of the mercury. Oh, good point, we'll take care of that. So, Winters I think does green, everybody else does blue. And when you see mercury, chances are it's either silver or red, and it's time to remove it. And that's a big plus walking through with this, because I've been in some universities, and a lot of the thermostats were removed because they all had the mercury bulb in them, so they were all taken out. But because the old thermometers are down in the basement, not near the kids, they don't bother taking them out. Well, they might as well take them out now, because you're going to have to take them out later. At some point, they will be inspected and they have to take them out. And it's only getting more expensive to get rid of it. We don't want it back. They generally, those institutions generally have places where they can move their hazardous waste to, and that's what you don't want it back here either. So, and then we do the dial thermometers, which is basically taking a gauge, putting a bulb on the bottom. Before World War II, if you wanted a dial thermometer, that's the way you had to go with it. Almost like that. Then the bimetals came out. These are still in school specs. I don't understand why. I've gone to people and I said, I can give you a bimetal for 1/3 the price of a dial thermometer. Well, the dial thermometer is in the spec. I said, okay, that's fine. You can't change them. But yeah, the bimetal for some reason in the schools, I mean, that is primary. You get into process. It's interesting. You get into the oil fields, anywhere into the, of course, if you're in pharmaceutical, these are in the basement in the pharmaceutical. Those are in the process. But that's even changing. You're not seeing as many of these. They're not putting these in there anymore. They're moving to the bimetals, because the bimetals, basically there's nothing to break. Occasionally we get a request, they want it silicone filled, because they read that and silicone is what has to go into a bimetal for temperature for whatever reason. But because a gauge gets liquid filled, we want to fill our bimetal. You don't need to have a bimetal filled. There's not the moving parts, even though that coil does turn. There's not the moving moving parts like there are in a gauge. They don't need it. And silicone, again, you close it, the pressure, hot, cold, it has the potential to leak. So that kind of, I'm over time. Just a little.
Pretty close.
Actually,
Pretty close.
probably, we had a little late start. That's kind of it in a nutshell.